Hey everybody, welcome to part 6 of our Radio Basics Troubleshooting course here. So if you remember where we left off in part 5, I'll just recap that for you and then we'll move on to what we're going to cover today. So in part 5, the first thing we discussed was getting the radio back to baseline. And as you recall, we removed all of those .47 caps that someone had put in a long time ago and replace them with the proper values that the radio is designed for. So we showed that. And then we discussed, when you have a problem with the radio, how do you start? Do you do the shotgun method, which is just ripping out all the resistors and caps and that kind of thing, or do you use something a little more methodical? And what we discussed was the methodical method, and that was basically separating the radio into two sections. We all know when your signal path comes in on the antenna, that's your RF section, right? That's where your radio frequency is getting stripped down to deliver the station. We know that radio stations send out a carrier signal, and basically what the RF section of your radio does is decode that and pulls out the station that you're looking for. And then when you get to the volume control, right in the center basically of the radio, that's where you start to make the transition into audio frequency. So the radio basically has an RF section and an AF section. So we did a test by touching a bare wire. In my case, it was a meter lead with nothing connected to it, to the center tap of the volume control. And the theory there was if you hear audio coming out of the speaker by doing that, you can pretty much be assured that your audio section is working. Now, in this episode, we're going to assume it's not, and we're going to go through the steps that are necessary to troubleshoot the audio section. And it's really not as daunting as it sounds. It's really very basic. So what I'm going to do is, first of all, I'm going to show you here on the schematic where we're going to be looking, and then we're going to actually go through the steps and show you that. Also, before we do that, we're going to be demoing and testing a brand new piece of equipment that I have. It's the BD signal tracer, and this is a joint venture by our good subscribers Doug or Moslack, Doug's Electronics Repair Bench, and Bob Gibbons. They've put their heads together and created a signal tracer which is very lightweight, 9-volt. It's a kit right here. You put it together yourself. Great little piece of equipment. I never like working with signal tracers that are plugged into the wall, and I have a few of them. I just have a thing about that. So I'm appreciative to have this device, which is run by a 9-volt battery, and you can do RF and AF with it, and we're going to use that for our testing today as well. So there's also a video that I'm going to put up separate to this one that shows me building the kit. Wasn't done very, very smoothly, but it shows you how it was built. I'll also put the link to their website and their email if you want to order one. Really, really cool little project. Takes about 45 minutes to build. Very simple, very clear instructions. Really good stuff. So let's get jumping here. Let's take a look at the schematic first, and what we're going to do is take a look at the spots that we're going to be testing. So obviously, first thing you want to do before you start testing anything is you want to check your B+ voltages again on the plates and the screen grids of the audio amplifier tube and the output tube. Now, we already did this, if you remember, in the last video, but we're going to do it again. So that's the first thing we're going to do. And here's the spots. I'll show you with arrows where we're going to be checking. Right there. Then we want to check the voltages of the control grids on the tubes in the audio section. And we know that the voltages on these grids should all be negative. If any of them are positive, we probably have a bad or leaking coupling capacitor, and they'll have to be replaced. Now we know, in my case, I've replaced all the film caps, but there still are some mica caps in there, so you never know. The next area that we have to check is the cathode bias resistor on the output tubes. And those resistors may also have an electrolytic capacitor bypassing them. So the capacitor should also be checked and replaced if it shows signs of leakage. Again, I replaced all the traditional film caps, but we're going to check it anyway. And then we're going to check the output transformer and the speaker. All right, we've already checked the primary of the transformer, right, on the output transformer by making sure that we had B+ on the plate of the output tube. So we know we have that. However, There also should be a capacitor across the transformer primary, or a tone cap. And this cap should be checked for shorts and leakage. We'll show you that. And then lastly, we should disconnect the speaker and test the secondary of the output transformer, and it should show connectivity or continuity. And then the last test is we should test the voice coil of the speaker and make sure it has continuity and is not open. Now you got to take a look at this, and remember, by following this procedure, we didn't replace anything. All we did was check a few key points and key places, and we should know exactly where to focus. Once you do this, if you have a radio with no audio output, you should be able to then touch a wire or your meter probe to the center tap of the volume control again and hear a hum. And then you'll know that your audio section is working. Okay, so let's do that now. We'll go through that procedure, and then we'll figure out where we're going to go from here. So let me get set up for that, and we shall return. Okay, so let's get our test cooking here. So the first step that we said we were going to follow is we were going to check to make sure we have B+ voltage on the plates and the screen grids of the audio amplifier tubes and the output tubes. We know in this radio that those two tubes are the 6SQ7, okay? That's the audio amplifier tube, and the output tube is a 6F6. In this radio, those two tubes are right here, and we know that the plates in the 6SQ7, the plate is on pin 6, and in the 6F6, the plate is on pin 3. So we're going to take our meter right here. We've got it set to DC volts. We've got a ground connected here, and this is a good time to remind you, when you're playing with voltages under this thing, you got to be really careful. No watches, no rings, no jewelry, nothing. And you always just use one hand, never two hands in there, because you'll complete a circuit and kill yourself. So we have our ground connected to the chassis. Let's turn the radio on. We're going to give those tubes a moment to warm up. We're going to connect our antenna because I want to pull the station in. Keep in mind this radio requires an alignment badly. Okay, I'm going to lower that. All right, so the first thing we're going to do is check the plate voltage. All right, again, on the 6SQ7, the plate is on pin 6. So we're going to take our light, make sure it doesn't get in the way of the camera. I'm going to make sure we're looking at pin 6. So there's 1, 2, 3, 4, 5, 6. Pin 6 is right here. And you'll see we have 110 volts DC on the plate. That's great. And then we're going to check our 6F6 tube, and that's pin 3. 1, 2, 3. There's pin 3. And we have 266 volts on the plate. So we know our plate voltages are good. Then we're going to look at the grids. On the 6F6, the screen grid is pin 4. So it's right here. And we have 284. That's good. Now we're going to check our 6SQ7. Sorry about that, my battery died. So we're going to check the grid on the 6F6. I'm sorry, on the 6SQ7, which is pin 4. Let's go there. And you'll see we have a negative voltage like we're supposed to, minus 4.8. And we're going to go back and check the grid on the 6F6. Let's do that. Okay, now I'm not getting a negative voltage here, and I need to double check my work. So there is pin 3 of the 6F6, and I'm getting 259 volts. And I'm getting 277 volts there on pin 4. So let's take a look at our schematic and see what we're supposed to have. So we're supposed to have, let's see, 277 on the grid, so that's normal. The plate we have 258, so we're good there. The screen grid, let's see, which is right here. And there's our cathode. So let's check our cathode first and get that out of the way. That's pin 8. And again, we're focused on the output tube right here. We're getting 14.9 in the schematic, Coil's for 17.8, so I'm good there. So the only thing we're missing is the screen. So what do we do? Something doesn't look right. Well, we're going to look the tube up in our book here. So we're going to look up a 6F6 and see what we're supposed to have. So let's flip to that and make sure I have the tube pins right. So here's our 6F6. Let's take a look at this together. So the 6F6, the plate is pin 3, which we have marked correctly. The heater is 2 and 7. Looks like we have 3 grids here, pin 5, pin 4, and pin 8. And let's see what our voltages are supposed to look like. So the grid number 1, it says it right here in the book. Grid number 1, which is the control grid, is supposed to be a negative voltage for fixed bias. So grid number 1 is pin 5. So let's take a look at pin 5. 1, 2, 3, 4, and 5 is right here. And I am a little bit all over the place, but I'm not negative. Let's move the station. So we don't have negative voltage there. What do we do? Looks like we may have a problem, right? So it says if any of those are positive, we probably have a leaking coupling capacitor, and they'll have to be replaced. Now, we do have a capacitor right here, which I've replaced, but you'll notice right here there's a resistor tied to this. Same leg of the tube. And by the looks of that resistor, let's see, it's yellow, brown, yellow maybe. So it looks like it may be let's see if we can find it, 470K. It's right here on the schematic, coming right off of that screen. So we want to check the voltages coming off of that. So we're going to change that resistor. That resistor looks like it may be causing us a problem. So we're not getting the proper negative voltage on this connection, this control grid. Okay? So I'm going to turn the video off. I'm going to go replace this resistor, and then we're going to come back and check it and make sure it's right. Okay? We'll be back. Okay, we've taken out the resistor and I've tested it, and it shows about 390K, but there's one thing I want to show you. I did a visual inspection of the resistor, and if you look on the top yellow band, see that crack? Right there. So this resistor has a problem, doesn't it? So remains to be seen if replacing it is going to help us, but at least we've got some kind of indication that this resistor is in trouble. Which is good that we're replacing it. It's important that we do that. So let's go ahead and replace it, and we'll come back and show you what happens. Maybe it'll make no difference. Who knows? Be back. I'm going to replace this resistor with the pigtail method, where basically you take one end of it and you roll it into a coil and you slip it over the lead. There's 2 ways to do this. You can do the pigtail method. You could, actually 3 ways. You can solder directly to the tube socket, which I'm not going to do because that will disturb and potentially break the pins. Or I could use the J-hook method. I prefer to do this. So basically I'm just wrapping it around a little screwdriver, creating the coil, putting this back together like this, squeezing it, making sure I got a good solid connection. Then I'm going to take this lead down and bend it, and I'm going to bend this coil into the position that I need it in. I'm right around there. And you'll see we'll just slip that right over there and solder it in. That's a good little tip for you. So you've got coil, J-hook, basically like this, or you can try to desolder the terminal pins of the tube socket. I wouldn't do that. Be back. Okay, and just like that, our resistor is soldered back in. We're going to clean the solder joints with some alcohol with an acid brush, just to make sure we get any flux off of it. We don't want that flux hanging on there. That's not a good thing. All right, we're good to go. Okay, let's power up this radio again and see if we have any improvement on that voltage. Let's plug our speaker in. Let's plug in our radio. Of course, when you do any soldering, you unplug the radio. That goes without saying. Let's take one last look, make sure everything is safe. Good. Okay. Let's turn the radio on. We'll turn this light off so we can see a little bit. I think we're better off with it on. Let's move this over so you can see the meter. There's our meter. Okay. Here's our probe. We're going to put this back on DC volts. Radio's on. Let's give it a moment to warm up. Then we're going to go back and check pin 5, which is our grid. We're going to give those tubes just a moment to start conducting properly. Let's see what we got. So if you remember before, we were getting about 4 volts, I think it was. That's much better. You notice as I tune, it changes. Still not negative. Okay, so you'll see that we still don't have a negative voltage there, but it's definitely better than it was. So what else do we have to look at here? What else could be contributing to this? Well, you'll see here on the schematic that we have another 470K resistor that ties directly to the resistor here that we just changed, and that is, let's zoom in, this one right here that's hiding underneath there. See right there? That resistor hasn't been changed either. So I think what we're going to do as a course of action is we're going to replace that one as well. Just looking at it from this angle, I do see it also has a chip in it. So I'm going to replace that resistor because it definitely connects to the same points as the capacitors do. And we're going to change that only because I don't like the looks of it. I'm not shotgunning here. I don't like the looks of that resistor. To me, it looks like it may have been some damage at some point. So we're going to go replace that, and then we're going to do our test again. We'll be back. Okay, this resistor's been replaced. Just soldered it, just cleaning off the flux on there, and we now have a new resistor there. The resistor that I took out of there, again, measured about 390, so just slightly out of tolerance. We'll see if it makes a difference. We're going to put our meter back on the DC volt scale. We're going to connect our negative side to the chassis. We're going to take our lead right here, untangle all the wires, and again we're going to check the screen grid, or the control grid, I'm sorry, of the F6 tube, which is the output tube. Let's plug our radio back in and see where we go. Okay, let's do one last visual before we turn it on. I think we're good. Radio on. You could see the meter. Let's give those tubes just a moment to warm up. All right, here we go. Okay, we still have a negative voltage there. I just took the antenna off for a moment. So we're going to have to investigate that one a little bit further. Now, fortunately on this one, we know that the audio section works. But I want to understand why I don't see a negative voltage there when the book calls for it. I could have a flaky tube, right? There could be a couple of things here, so I'm going to want to test that tube out and make sure that it works properly. And that's going to be, I think the right thing to do. So the next step is the cathode resistors. And in this case, the cathode resistor for this radio, for the output tube, which is the 6F6, is a 390 ohm resistor. So we're going to check that. And on the, let's see, on the cathode of the 6SQ7, that actually feeds down to a 470 ohm resistor, which we've just replaced. So we know that one's good. So we're going to check the value of this resistor. We're going to turn the radio off. Okay, radio's off. We're going to unplug it. And we're going to move our leads. One is right here. And we've got our meter, and I'm expecting to see 390 ohms. Let's see what we get. Getting about 338. Definitely within tolerance. So this is good enough to go, although I'm going to replace these resistors. I don't like the way they look. But our cathode resistor here is good, and of course our cathode resistor on this one is also good. Hold on a second. Let's look at our schematic because I'm not getting the reading here. Let's see. Okay, this 470 comes up here and goes to the screen grid of the 6F6. This one goes to ground. Okay, there you go. So this should be pin 4 on this one. And it should come right there. There we go, 470. So by checking the schematic, we're able to zero it in. So we know that our cathode resistors, or the bias resistors, are good. And we know that these electrolytic capacitors that they're connected to also are good because we've just changed them. So the next thing we're going to do is we're going to take a look at our output transformer. And we're going to make sure that we check the windings there. So I'm going to get that set up and I'll be right back. By the way, before I leave, one thing you'll notice is that I'm kind of plugging along here as well, right? I'm not the expert on this radio. I'm simply following the clues, following the schematic, following the leads, making sure that I'm looking in the right places. But we know that we're close. I just don't understand why that we're not getting the negative voltage there, but we will. All right, we'll be back. So before we move on to the output transformer, this negative voltage on the control grid of the 6F6 has been bugging me. And when I look at the tube data in the book here, if you look right here, I'm going to see if I can get you to see this. If you look at the control grid number 1, which is the control grid voltage, if it's a fixed bias set, it's negative 24 volts. But if it's cathode biased, there's no reading expected. So that begged the question, well, is this thing a fixed bias or a cathode bias? So the way to determine that is if the cathode of the 6F6 tube goes right to ground, it's typically a fixed bias. If the cathode goes through a bias resistor to ground, or B-, it's cathode based. And according to our tube data, it's cathode based, so we shouldn't be expecting to see negative voltage. How can I prove that? Well, taking a look at our diagram here, here's our 6F6 tube, and here's our cathode, and our cathode comes around here and goes to a resistor, which is right here. This is the 390 ohm resistor I mentioned earlier, and goes right to ground. So in our radio, I did replace that 390 ohm resistor I showed you. I had these two paired together. Someone didn't have a 390, so they put together two 690s. Not sure why. But I put in a 390 right here. So we're going to call the voltage good on this, and we're going to move on to the next section. So we've all just learned something together about fixed bias versus cathode. Fixed bias means that the cathode goes right to ground. Cathode bias means it goes through a bias resistor to B minus or ground. Okay? This particular set has that. Now, keep in mind, other tubes may use a different type of biasing, right? We're talking specifically about the output tube here. The other tubes could be doing a different type of bias, and we're not going to get into that right now. Let's get to our next part. Okay, checking our output transformer. The first thing we want to look at is we want to look at, well, first of all, keep in mind that we've already checked the primary of the transformer, right? And we know that because we have B plus on the plate of the output tube, the 6F6, which is right here. However, there also may be a capacitor across the transformer primary, and they call this a tone cap. And in this case, if you look at the schematic, you'll see right here, coming off the cathode, over here is a 0.01 microfarad cap, which goes to the primary. That's going to be this cap right here. Here's our cathode. And this cap comes right here, and then there's a wire here that goes top side to the speaker. So this is our 0.01 tone cap. We know this cap is good because we've replaced it, but you want to check this cap here. This cap will help you with that problem. You want to check it for shorts and leakage, that type of thing. So at this point, we know that that output transformer is good. We want to disconnect the speaker and test the secondary of the output transformer. And we know that it should show connectivity. So, in order to do that, we're going to disconnect the speaker, which we've done, and we're going to take our our leads here. I'm going to remove this clip. Okay, so we're going to check the output, the secondary of the output transformer. Now, notice in this radio, there is no output transformer connected to the chassis. It's mounted to the speaker. Here's our output transformer right here. So, we're checking the secondary, and if we look at the schematic right here, it tells us that we have our primary of 460, and then we have our secondary. So let's see what we have here. There's our 460, and that should be our primary. Let's take a look at the other side. And we're about 1.5K, and that seems about right. So I would say that both the primary and the secondary on this speaker are good. And lastly, we want to check the voice coil, right? And the voice coil, and every speaker is different, but essentially if you look down on the speaker, you'll see that our voice coil is connected right here like this. And we get 0.8 on our voice coil. So we've now checked everything back to right up to the actual speaker, and we know that our audio section is good. Okay, so so that should help you in a very layman's way of how to check this thing from end to end and know exactly what you're looking for. So just to recap, we checked our plates and our grids from the audio section, which here is the 6SQ7 and the 6F6. This is all audio at this point. And we've ensured that we had the proper voltages. We know that we had negative voltage on the 6SQ7, which is expected in the control grid. 6F6, we don't need it because we're cathode biased. So what we're going to do now is we're going to put everything back together, and I'm now going to demonstrate the BD signal tracer and show you how that works. So let me get that set up. All right, so here's our BD signal tracer. Just to do the setup, I have the BD signal tracer set for audio. I have the negative lead connected to the chassis, and all I'm going to simply do, I have the volume all the way down on the radio, and I'm going to touch the other side of the probe to the center of the volume control. Let's see what we get. Actually, we're not on the center, we're on one side of it. Now the reason why this is so distorted is because this is a very strong station. I need to do an alignment on this radio. That station you hear comes across the entire dial. which tells me that only 1/2 of the tuning cap is working correctly. It needs to be aligned. But I'm proving without any volume to come through the speaker that I am getting audio on one side of the pot. Right there. Let's be careful. I'm tuning around. And like I said, you're hearing that same station as I tune around. But that's essentially how this works. If I change this to RF mode, like so, I should be able to pick up something on the 6SA7 and the 6SK7. Let's see if we can pick that up. Maybe we want to go over to the plate of the 6SK7 first, which is pin 8. Let's see what we get. Now we're in RF mode. I'm tuning the radio. That's good. Let's also go over to the 6SA7, the plate, which is pin 3. Okay, so I'm picking it up on the 6SK7. I'm not picking it up on the 6SA7 yet. Let's make sure we have the right pins here. There it is, right there. Okay, so our signal tracer works. So basically what you're hearing is it's not going through the audio circuit, right? When we split the radio in half, we're not hearing anything through the audio. We're hearing the introduction on the very first tube, which is the 6SA7 that attaches to your antenna. We're hearing the signal coming in first. And as it goes through the other stages, the other IF stages, it gets amplified and that gets converted to audio. So you're hearing that our radio is indeed oscillating and picking up the station. And I can turn the dial. Now again, on this radio, it's not going to pick up much because it needs to be aligned. But you could hear it there. And then as we go to the next stage, which is the 6SK7 on pin 8, you can hear it right there. So that's how this thing works. It's very, very simple. We're going to turn the radio off for safety. And you'll see that you're able to trace the steps through the RF section and the audio section, and this is a great little device. I suggest you think about getting one of these. It's portable, it's compact, works really, really well, gets the job done. Right? It's a satisfying kit because you build it yourself, and you know what's inside of it, and you can use this for a long, long time with a 9-volt battery. It does have true shut-off, so when you shut off the unit, it's not draining the battery, which is always a good sign because a lot of the cheap electronics you buy out of China today, when you turn it off, it's really never off and the batteries drain out. So this one does a really fine job, and hats off to Doug and Bob on this thing. So this thing works really good. Okay, I have one more thing to cover with you before we wrap up, and let's flip this thing over topside for a second. I'm going to unplug the speaker. We're going to unplug the radio so I don't get electrocuted. Okay. So you'll notice here that I've replaced the second can. And I replaced the second can because on further inspection of the can that was in there, you'll see that it was collapsed in one side and pushing on the coil. As a matter of fact, in order for me to get it out, I had to rip it apart like this. And what I found was that the actual case was touching the coil. So I wanted to replace it anyway to get a better look, so I've replaced it. And when I put it in here, after I put it in this can, I used fish paper. Doug Moslak, our friend Doug, just recently did a little video about fish paper, which is basically this stuff. It's basically cardboard. So if any of you have ever ripped open an IF can and you see that brown paper inside, that's what this is. It's an insulator. That's all it is, right? It's insulated paper, and it's pretty rigid and strong. Doesn't break down over time, which is good. Matter of fact, a lot of the cans that I've opened up over the years, the paper is still intact. It is fairly brittle, but after 80 years, I guess I'd be brittle too. So we put new fish paper inside here, and we're good to go. I was also troubleshooting this thing and found a problem which I didn't record. I wish I did. So what was happening is, as I was turning this dial, I would, on this end of the dial right here, I was getting static, a 455 kilocycle tone. And I'm like, what the hell is that, right? And what I found was that this tuning cap right here is bent. And it was, when I have it wide open, these fins are not touching. But when I had it closed, there was a short in here. So further inspection on this thing, I'm going to have to remove this tuning cap and clean it. It's very, very dirty. And that will give me an opportunity to fix these push buttons as well. And of course, I'll get to old 64 Goat's favorite part of restringing the dial, because I know that Bill loves that stuff. Matter of fact, when he goes over to Jewett City, the first thing he looks for is a radio that he can restring, right, Bill? So the next step here is going to be to remove this entire tuning mechanism. There's one wire on top, and there are two wires here on the bottom. That's it. One here and one here. And we'll be able to take this whole thing out. We're going to throw it in the bath of, in the ultrasonic cleaner with a little bit of degrease. And we're going to clean it up. We're going to polish it just like the rest of the radio. And that will give me an opportunity to finish the chassis and get the chassis nice and shiny. And get a little bit of rust off here. There's some rust on this wheel. And then I want to see how I'm going to fix these push buttons. And these push buttons, every piece of this fabric is broken right here. So I got to see how I'm going to fix that. So I don't even know if the push buttons work, quite honestly. We're going to find out. So so that's going to be the next step, and I will show you in the next episode how that looks when I remove it and clean it and put it back together. So I hope you learned something here, and I'm trying to do my best here to show you. So in our next episode, which is episode 7, we're going to assume that the audio section is good, and we're going to go into the RF section and troubleshoot that a little bit more. All right? Sorry for the learning nature of this thing, but as I go along, I'm learning with you. So if anybody has any questions, let me know. And again, I have to give credit to Brendan. Brendan is he's a good friend and he's a mentor, and he is helping to guide me through this journey. And I'll tell you, it's helping me a hell of a lot. So I'm learning along with you, like I said. So hats off to Brendan. Hope everybody has a good week and rest of your day, and stay safe out there. We'll see you.